Hello, we are going to review functions real quick. So remember, for something to be a function, we use the rule that each x must have one y value. So looking at this first example, I see I've got a -2 for an x value and also a -2 for an x value here. They have different y values, so this would not be a function because -2 is paired with 1 and 3, not a function. In the table here, I've got 0, 3, -3, and 2 for my x values. They're all different, so this is a function. They each are only paired once. For graphs, we have our vertical line test. So that's where I draw a vertical line. You can put it anywhere on the graph and it only crosses once. It is a function. But if I draw a vertical line and it crosses more than once at the same time, it is not a function. Then down below, we are also going to review linear and nonlinear functions. So for a graph, a linear function just needs to be what that word linear means, and that's a line, a straight line. It could be a positive slope or a negative slope or a zero slope, but it has to be a perfectly straight line that you could trace with a ruler. Nonlinear is really any graph that has a curve to it. I'm going to give you a couple examples. It could be something like that, that's curved, or it could even be something that's made up of a couple straight lines, but if it's not just one straight line, it's nonlinear. So that second example would be nonlinear because it's not just one straight line. Can't trace it with a ruler. For a table, we are looking that the table has a constant rate of change to make it linear, meaning it's increasing or decreasing by the same amount every time. So this looks like we are going down 5 for the y values. And the x values, 3 to 6 is +3, 6 to 9 is +3, 9 to 12 +3. This is a constant rate of change because that pattern is staying the same throughout the whole table. If I increase the x's by 3, the y's go down by 3. For this table, my x's, 0 to 1 is +1, 0 to 2 +1, 0 to 2 to 3 +1. Those are all going up by 1, so let's look at the y's. From 1 to 3, I added 2. From 3 to 6, I added 3. And from 6 to 10, I added 4. So this is nonlinear because that pattern is not the same throughout the whole table. Sometimes I added 2, sometimes I added 3. Even though it's kind of a predictable pattern, it's nonlinear because it's not a constant rate of change. It's not the same throughout the entire table. And lastly, we have equations. Remember, for something to be linear, you want to be able to write it as y equals mx plus b. Y equals some number times x plus another number, or it could be a fraction. Like x divided by 2 is the same as 1/2 x. And then we could do a -4. You want it x in the top or just a plain x. Whereas nonlinear, something else is going on with the x. It could be x is on the bottom, so I could have 2 over x. Or it could be maybe there's an exponent in x squared. Either of those would be nonlinear.